Good afternoon to all. This is A. Shakira Parveen, working as an assistant professor in the Department of Electronics and Communication Engineering. So now let me see a topic in image processing and computer vision. So the topic is local histogram processing and histogram statistics for image enhancement. So this topic comes under the unit 2, image enhancement and restoration. So first, local histogram processing. So the histogram processing techniques are easily adaptable to local enhancement. The process is to define a square or rectangular neighborhood and move the center of this area from pixel to pixel. So this function is finally used to map the gray level of the pixel centered in the neighborhood. So the center of the neighborhood region is then moved to an adjacent pixel location and the procedure is repeated. So first, what is histogram processing? So it is the repetition. So it is the frequency of occurrence of gray level in an image, gray level in an image, pixel in the image. So that is processed in a particular area. Then that is said to be the local histogram processing. So for localized processing, it is termed as localized histogram is said to be the localized histogram processing. So this is the example of local histogram processing. So if this approach sometimes to reduce the computation is to utilize non-overlapping regions. So but this method usually produces an undesirable checkerboard effect. So the figure A is the original image and figure B is the result of global histogram equalization, and the third image is the result of local histogram equalization using 7 cross 7 neighborhood about the each pixels. So the level of occurrence of gray levels is increased from one image to the another. So this is the difference between the local histogram processing in all these images. So local histogram processing. So in that, note that no new structural details were brought out by this method. So however, local histogram equalization using a 7 cross 7 neighborhood revealed the presence of small squares inside the larger dark squares. So this is the histogram statistics. So first one is the mode and the second one is the median. So the mode is the value that occurs most frequently in a distribution and is usually the highest point on the curve. And the median is the value midway in the frequency distribution. One half of the area below the distribution curve is to the right of the median and one half to the left. So next is the smoothing linear filters. Smoothing is often used to reduce noise within the image. So image smoothing is the key technology of image enhancement, so which can remove the noise in images. So it is a necessary functional module in various image processing software. So next is spatial filtering. So spatial filtering term is the filtering operations that are performed directly on the image pixels on the image. So the process consists simply of moving the filter mask from point to point in an image. So it has two types: smoothing spatial filters and sharpening spatial filters. So smoothing spatial filters. So smoothing filters are used for noise reduction and blurring operations. So it takes into account the pixels surrounding it in order to make a determination of a more accurate version of this pixel. So smoothing spatial filters consist of two types: linear and non-linear spatial filters. So in linear there are three types: mean, Wiener and Gaussian. In non-linear there are three types: min, max and median. So smoothing linear filters is the average of the pixels contained in the neighborhood of the filter mask. So averaging filters or low pass filters consist mean filter and Gaussian filter. So mean filter or box filter. So mean filtering is simply to replace each pixel value in an image with the mean or average value of its neighbors including itself. So let's consider this example. So in that the center value 20 is the mean value. So which takes the average. So all the 9 pixel values has to be added and divided by 9, then we will get the average, that is the mean value that is placed in the center of the image, center of the pixel value. So mean filter or box filter, so which has several examples: 3 cross 3, 5 cross 5, 9 cross 9, 11 cross 11 box filters. So various images examples are shown. So mean filter or box filter drawback is smoothing reduces fine image detail. So Gaussian filter, so the Gaussian filter smoothens an image by calculating weighted averages in a filter box. So it is used to blur the images and remove details and noise. So that is the expression for Gaussian filter. So Gaussian smoothing example, so this is the original, left side is the original image and right side is the after Gaussian has been taken, which is sigma is equal to 3. So sharpening spatial filters, the objective of sharpening is to highlight fine detail in an image or to enhance detail that has been blurred. So that is the sharpening. So sharpening spatial filters expression is termed as del f by del x is equal to dou f by dou x is equal to f of x plus 1 minus f of x. So sharpening spatial filters, second derivative value is dou square f by dou x square can be taken as f of x plus 1 plus f of x minus 1 minus 2 f of x. So this is the example of sharpening spatial filters. First one is the simple image and the second one is the 1D horizontal gray level profile and the third one is the simplified profile. So sharpening spatial filters, in that the number of gray levels were simplified to only 8 levels, and we note that the first order derivative is non-zero along with the entire rank. So sharpening spatial filters have next we encounter the isolated noise point. The second derivative is much more aggressive than a first order derivative in enhancing the sharp changes. So this is the corresponding expression for sharpening spatial filters, second order Laplacian equation. And this is the example of sharpening spatial filters, filter mask used to implement, and implementation of Laplacian. So this is the example of sharpening spatial filters. So first one is the image of the north pole of the moon. Second one is the Laplacian filtered image. Third one is the Laplacian image scaled. And fourth one is the image enhanced. So that's all about the local histogram processing. So local histogram processing can be taken for both the image processing values and it can be implemented in computer vision techniques. Thank you.